Hello, I'm here today to give you an update on our plans to implement General Physics Online in the fall of 2010. And as this slide says, the structure of this course will be we will discuss its content delivery, how we are going to do student contacts through recitations and office hours, all of this online. And also I will discuss how we are going to do the assignment. For the fall of 2010, we have two sections. One, Physics 111, that is going to do by Stuart Lindsay, and one section of Physics 112 that is going to do by me, and both of them are going to be online. The content delivery of the lectures will be done by video modules, and this is something that Stuart Lindsay does regularly now for his nanoscience class, and I've been doing that also to helping students to do homework. There's going to be a traditional textbook associated with the courses, and this book is also in an electronic form that is fully integrated into WebAssign, and we want to really exploit that feature. The courses are divided in 4 recitations instead of 8, like a traditional large lecture class will be divided in. So these 4 groups will be once a week with a TA through Adobe Connect online. And the TA will also have office hours online, and the instructor will have office hours online. The assignment, everything is done through WebAssign, and I will show you in a little bit some of the features. Of course, the starting point is Blackboard, and what you see here is the entrance page of Blackboard from my section of Physics 111 this semester. Let me right now go into the recitations online. So the students, depending on the time of the week they meet, they have their links to their recitations available to them, and these recitations get videotaped. So they can, if they didn't attend it, they can watch it later on. And this is one of the latest one that Joel has done. So let's just take a look at what he does.
Yes, so welcome back. On Monday, that is yesterday, you guys started discussing conservation of energy, is that correct? With Dr. Alarcon? Cool. Okay. So yeah, I just wanted to, briefly remind you of some of the things that you guys should have talked about, and then ask a couple of questions and go over them. And then if there's time, we'll answer any questions you guys have. So one of the things that you guys should recall is that if only conservative forces act on some isolated system, then energy is conserved, right? And one of the ways that we might write the statement of conservation of energy is just to say that the kinetic energy initial plus the potential energy initial will equal the kinetic energy final plus the potential energy final. Okay, so this is a statement of the conservation of energy. Another theorem that you guys should know is this work energy theorem, okay, which says that if only a conservative force acts over some distance and does some amount of work, okay, then that work will be equal to the change in the kinetic energy. Okay, so it just says this, right? So K final minus K initial, like that. And recall again that work is a force times a distance, right? Okay, so that if the force is constant, then you can just simply solve for a distance, for instance, okay, by taking the difference in kinetic energies and dividing by the force that's applied. Okay, so with that in mind, I wanted you guys to check out this question and see what you guys thought of it. Okay.
So Joel uses this way of starting his recitation class. He warns them the map as they are coming in. So he put up a question that the students will answer in about a minute or two, very similar to like you do with the CPS systems in lectures. And he will get feedback. He will get a histogram here of how many of them got it wrong, how many they got it right, and then the discussion takes place. Now, lectures will be delivered, as we said, through video modules. And these video modules can be produced, for example, through YouTube, and they can be embedded directly into Blackboard. For example, here are the videos that I have produced to help my students with their homework assignments, and the students like them a lot. They see them a lot. What I want to show you is to go to what Stuart Lindsay's been doing with his nanoscience class. He has produced all the videos relating to his textbook, and let's just listen to him.
So congratulations, you've reached the last chapter in the book, Nanobiology. In this module we're going to give an introduction to some terms, and in the next outline some basic molecular biology. We're going to discuss enzymes as nanomachines, molecular motors, and then end up with a discussion of fluctuations both in gene expression and gene splicing. Biology is the ultimate example of a system that is completely dominated by fluctuations. This was recognized by Charles Darwin in the 1840s when he produced the basis of his monumental work on evolution by natural selection. Darwin noticed that there were random variations in the way that a species appeared.
Stuart uses a very effective way of combining PowerPoint presentations with a whiteboard, and so later on in the lecture he will go to the whiteboard and write things down for the students, and of course all of that gets recorded.